In terms of speaker bios and presentations, for bios on this session, we do have a lot of content and discussion to go through today. So we're going to ask that you can either scan this with your phone, or once I hand it over to Kyle, I'll drop the link to this session, which will give, again, an overview of the session today, along with a bio, a speaker card of each of our presenters. You can click on that speaker card and it'll pull up their complete biography. So we'll hope you'll take the time at some point during the session today to take a look at that. So again, I'm just going to reiterate, welcome everyone today. This is for day 3. This is part 2 of this morning. We had an 8:30 morning session, and now we're at the 10:30 session. And again, this is unlocking value in waste tires recycling, the power of devulcanization. So with that said, the next one, I'm going to go ahead and hand it over to Kyle Pogue from CalRecycle to say a few remarks, and then we'll transition to Denise Kennedy.
Yeah, thank you, Tommy. Appreciate that. I too want to welcome you guys to this session today. I am Kyle Pogue, Environmental Program Manager here with CalRecycle, and helping facilitate this virtual tire conference. Our first session was indeed fantastic, talking about the retread industry. And I'm really excited about this next session titled Unlocking Value in Waste Tire Recycling, the Power of Devulcanization. And really want to thank all the contributors here for taking the time to share this topic with us. And it is my pleasure to introduce Denise Kennedy, the moderator for this session. Denise, take it away.
Unmute. All right, there we go. I want to say good morning to everybody, and thanks for being on this particular session, as well as the one if you were on the one earlier today, which was really good. I want to thank you for joining CalRecycle's 6 of 8 webinars in the Moving the Needle, a Strategic Pathway to Waste Tire Management series. Today's session explores devulcanized tire rubber from multiple perspectives, those of a leading researcher, a vertically integrated rubber recycler and manufacturing company, an engineer specializing in infrastructure, road paving, and paving specifications, and users who are successfully incorporating devulcanized rubber into commercial applications. CalRecycle is committed to advancing California's transition to a circular economy by increasing the diversion of waste tires from landfills. Through research, market development, grants, and stakeholder support, we continue to expand viable end uses for scrap tires. However, with approximately 59 million tires generated annually in California and over 325 million nationwide, significant gaps do remain in current markets and applications. In addition to our ongoing programs, CalRecycle invests in targeted research to better understand emerging tire technologies, identify innovative uses, and addresses technical and market challenges. That is why we are pleased to start off this morning with featuring Professor Anil Bhowmick. He's a research professor in the William A. Berkshire Department of Chemical and Biomolecular Engineering at the University of Houston. In 2024, CalRecycle awarded Professor Bhowmick a contract to produce a comprehensive literature review and evaluation report on the state of the waste tire rubber devulcanization technologies, which is undergoing review right now, so it's not published yet. It'll be reviewed by CalRecycle. Professor Bhowmick will kick off this session with a short 10-minute summary of all this great big report on the state of waste tire rubber devulcanization technologies. I want to encourage you to submit your questions, not in the chat, but because we won't see those, over to the Q&A. And then I'm not even sure we're going to have time to get your questions, but afterwards we will follow up if we have your email and your contact information when you registered. So we do think we're going to have questions that we may not have time. We have a lot of questions. So anyway, I'd like to first introduce right away our professor, Anil Bhowmick. He is the world-renowned expert in polymer science and rubber technology. His extensive research has resulted in 24 technology transfers to industry with significant real-world impact in tires, defense, automotive, and manufacturing sectors. I'm pleased to introduce him right now and take it away, Professor.
Thank you, Dennis. Good afternoon, everyone. First of all, I'd like to thank CalRecycle for inviting me to be here and giving me an opportunity. This afternoon, I'm going to talk about waste tire rubber devulcanization.
Professor,
we are going to talk about waste tire and recycling versus devulcanization, devulcanization methods, comparison of the methods, environmental impact, conclusion, and futuristic projection.
Hey, Professor,
now,
I'm going to interject for just a second. Go ahead and share your screen because we went off screen share. So before you move into it, and then we can go ahead and start.
Can you see my screen now?
No, not yet, sir.
We see you.
Is everything all right? I'm sorry about it. We set everything all right.
Yep, no worries. So if you see on your screen bar there, you should see the share button popped up, and so it should be sharing out on there. I'll go ahead and pull the presentation just in case we need to.
Share button is not coming.
Let me double check something. You do see the ability to share, correct, Professor?
Yeah, my window is not coming for some reason. I don't know why.
Maybe minimize one, and let's see if we can pull it over.
Anyway, in order to save time, I've sent you the slides, right? Can you share the slides?
Yep. Let me bring it up, and then I will just share my screen. You just give me an audio cue when you want to share. Let me make sure I'm bringing it up.
There we go.
Professor, are you seeing it?
He froze.
No, he's there. Denise, can you see my screen share?
I see your screen share, correct.
And you see Professor Neal's?
Yes, I can.
Awesome.
Yes.
So Professor, just give me an audio cue when you want me to go forward, and I'm happy to do that for you.
Okay. So what do I do from here?
Just go ahead and talk, and you're just going to let me know on your end.
Okay.
You should be able to see the slides as well, and you're just going to let me know when you want to go forward.
All right. This afternoon, I'm going to talk about waste tire and recycling and versus devulcanization methods, comparison of the methods, environmental impact, conclusions, and futuristic projection. Next slide, please. The term rubber recycling embraces all types of rubber recycling, which breaks rubber vulcanized into micron-sized powders or soft masses, severing main chains as well as crosslinks. On the other hand, rubber devulcanization specifically deals with crosslink scission without affecting main chains. This is shown in the schematics here, and you can see that how the crosslinks are broken down and without affecting the main chain. This is called devulcanization, and this is really a challenge. So devulcanization is a process that involves breaking the sulfur crosslinks in vulcanized rubber to restore its processability and plasticity. The goal is to convert waste rubber into a material that can be reprocessed or blended with the virgin rubber for new applications. Next slide, please. How do you know that you have achieved devulcanization? when you do devulcanization, you get lots of polymer back into the rubber compound. So you can measure the salt percentage. That means it goes into the solution. Those particular polymer that are released, that will go into solution. And you can measure that by ASTM D6814. And then also you can measure the cross-link density, which gives you an idea about the network. That means before, what was the network and or cross-link density? After you devulcanize, what is the network structure? And that gives you an idea. And if you want to specifically know that what is the percentage of sulfur-sulfur bond breakage versus main chain scission, you can do a Horrocks method for devulcanization study, which plots salt fraction against the decrease in cross-link density, which is shown on the right-hand side of this slide. And you can see that the points, if they're close to the solid line, that means more of sulfur-sulfur cross-links breakage. Next slide, please. Next slide. But before we do the tire devulcanization, we got to know what we are devulcanizing. Basically, we are devulcanizing rubber, but rubbers are different types of rubbers are used. Natural rubber, synthetic rubber. Even in synthetic rubber, you will find different types of synthetic rubbers are used in tire. You have filler, and also you have lots of other ingredients. Again, in passenger tire, the amount of rubber is different from the truck tire. For example, truck tire, you have more of natural rubber than synthetic rubber for lower head buildup, better crack resistance, and all these properties. Next slide, please. There are different types of devulcanization methods. One is thermal. Second is mechanical and thermomechanical. And if you put chemical into it, then it becomes mechanochemical and thermomechanochemical. Then you have the third category, which is chemical. You have ultrasonic devulcanization, you have microwave devulcanization, you have supercritical solvents devulcanization, and then you have biological devulcanization. These are all covered in my review to CalRecycle for details. Next slide. Since the time is short, I'm going to tell you only one method, which is the thermomechanical method, which is extensively used in this world, which is the batch mixer or extruder process. And you can use, for example, single screw or twin screw extruder, which is shown on the right-hand side here. And the procedure is first you have to get the pre-treatment, then feeding into the extruder, heating and shearing, devulcanization, and then you have to get the products by out of it through you have to remove that, and then extrusion. The whole process is an extrusion. The typical temperature is 100 to 220 degrees centigrade, RPM 80 to 200, and time is 10 to 40 minutes. As you know, as the processing temperature rises, the specificity of cross-link bond breakage diminishes. Hence, the temperature limit is 220. Beyond that, there will be a lot of bond breakage, and which is not desired in this particular operation. Next slide. We can compare different methods. For example, in chemical, we use lots of chemical agents, flexible, but you have the limitation, chemical waste or safety concern, mechanical, thermomechanical, or mechanochemical, or thermomechanochemical. You use shear, heat, and then chemical, low cost, easy setup, but your quality is inconsistent. Microwave, ultrasonic, in one you get microwave energy, another ultrasonic waves. These are high equipment cost, very expensive and complex setup in ultrasonic. Biological is really eco-friendly, but very slow, and you use microbial or enzymatic process. Supercritical is clean, but you use high pressure and high temperature. That is the limitation. And thermochemical, of course, heat and catalyst, and effective, but maintains the polymer, but it's a moderate cost, and catalyst management is a problem. Next slide. Now, there are different technology readiness level of devulcanization methods of these different processes that we just discussed. Chemical is 7 to 8 technology readiness level. The best one is mechanical or mechanochemical, thermomechanical or thermomechanochemical, which applies shear and heat with and without chemicals. Your technology readiness level is 8 to 9, extensively used all over the world, Europe, Japan, China, everywhere it is used. Microwave, it is 6 to 7, ultrasonic 6 to 7, biological, it is 4 to 5, supercritical, it's 6 to 7, and thermomechanical, it is 5 to 6. Next slide. Now I'm going to tell you about the environmental impact of devulcanization. That is a paper by Costanger. This study compared the environmental impacts of producing virgin EPDM versus recycled EPDM through devulcanization. Normalized environmental impacts based on 1 kg of virgin EPDM versus raw EPDM. And on the left-hand side, you will see the climate change versus resource use. And climate change impact was reduced by 79%, of fossil resource use by 91%, and freshwater ecotoxicity by 89% compared to virgin production. Next slide. This is the last slide. In conclusion, and for the future, hybrid techniques will be more and more popular. For example, mechanochemical or mechanochemical or biological combined with chemical. This will be more popular in future, but more options will be available to use the sustainable approaches, which is currently not there in terms of the chemicals used for devulcanization. So this is a big challenge area, and more work should be done in the sustainable approaches. Automation and AI integration still coming in this industry, and we have to do more work on this. One of the problems with the devulcanized rubber is the material property retention. The property is not the same as the original rubber, so more research is needed to improve the properties as close to the virgin material. And also circular economy integration challenges for tire recycling is very important. For example, tire to tire, original tire made from virgin material versus original tire made from recycled material. This is a challenge, and if you are successful, then I think devulcanization technology will be very much successful. But the hope is that the global devulcanized rubber market is expected to grow from currently about 700 million in 2026 to about 1.5 billion to 2034 at a 10% CAGR, which is very much positive on the positive side. Typical rubber growth is 4 to 5%, but recycled rubber growth is very high. In the US, reclaimed rubber revenue is forecasted to double between 2021 to 2028, and California recycles only 35% of tires, and most recycled rubber is used in low-value application at this moment, underlying the urgent need for higher value recycling like devulcanization. And thank you very much. If you have questions, I'll be available for answering them. Thank you, Dennis. Back to you.
Hold on. Thank you very much, Professor. Appreciate that very much for the short, quick overview of all that. The next thing we're going to do is I'm going to introduce myself a little bit on, and then I'll get into the rest of it here. I think if you know me already, I've been in this industry 38 years. I have been very involved in, my first 16 years was running plants, transportation in multi-states. And a lot of those facilities were purchased by Liberty later on, many years later. And then I have worked with CalRecycle as a subcontractor and contractor for 14 different contracts since 2006. I helped with the annual market study every year, and helped with product development and worked with about 3,500 labs. A lot of this came as a result of the work with CalRecycle. And then I have clients now internationally and nationally. So I just want to say that what's really important has been my involvement with ASTM. I do chair rubber recycling. CalRecycle supported that in testing rubber for particle size and using California rubber. I've also worked with David Parker, who is actually the chair of devulcanization in ASTM, and I am a subcommittee chair for recovered carbon black. So you kind of get to work with the tire manufacturers and the ones that are developing or utilizing different technologies now, which is great. This particular panel, we have, let's see, we've got exactly about 1 hour, which is what we thought. We have quite a few presenters, but this is going to discover how devulcanization unlocks higher value recycling pathways and enhances material performances, supports sustainable infrastructure and manufacturing. So I think this time, I believe they're putting a link on the Q&A, not the chat, that actually you can look up more about each of the presenters, but they're also going to have you're going to get to know them through this process. I'm going to start right off with our very first question, which is we have 5 categories. Our first question is, I'm going to ask each of you, David, I'll just ask you as time allows here. Can you, David, starting with you, can you briefly tell us about your company, the key products you manufacture, or the projects you support, and primary markets you serve?
Thank you, Denise, and thank you to CalRecycle for hosting this conference. NRT sells manufactured products and materials into the rubber replacement market, the thermoplastic elastomer market, as well as the asphalt modification market, with the asphalt modification market being bifurcated into both road paving as well as roofing products. The commonality in everything that we do is that we begin with what I will call end of first life material. Others may call it waste material, and we apply material science to be able to restore that material into a set of materials that have physical properties, processability, and form factors that are relevant to those different end market applications. And we'll go into how that's done through the course of today's discussion.
Thank you. How about Sean McGee from Legend Rubber?
Hello, everyone. I'm Sean McGee from Legend. My background, I've been in the automotive industry for about 20 years as a manufacturing engineer. The last 4.5 years, I've been at Legend, still at the same manufacturing engineer. Legend's a growing company. Basically, in the last 4 years, it started out about 35 people. Now it's upwards of 130 to 140 people. We have multiple locations in the States and the UK. So a lot of our products we make, we have a fleet side and we have an agricultural side. So the fleet side, which I kind of more specialize in, and we have like rigid floor systems. So different types of floors depending on what needs for cargo vans. We do wall liners. So we make our own wall liners with polypropylene kind of honeycomb material. So that would be your ceilings, walls, so you can kind of outfit your van that way. And also we do rubber mats. So this is where the devulcanization comes in. We do rubber mats. One of our big customers would be U-Haul for that. And then we do have a metal division as well. So we do all the accessories to vans. anywhere from steps to handles, all that kind of stuff. So we get into a lot of OEMs. We're in with Ford, Rivian. We deal with Amazon, and also we just deal with onesie twosies kind of people that have a fleet of vehicles or just one person just want to outfit their van.
Thank you, Sean. Next is going to be Don Sogren from Seneca Petroleum.
Okay, sorry about that. Had to unmute there.
Yeah.
Thank you, Denise. Don Sjogren, Seneca Petroleum. Seneca is a 104-year asphalt supplier in the Midwest. And we are involved in many specialty asphalt products as well. And for the last 25 or 30 years have done rubber modified asphalts, kind of actually one of the first to do polymer modified asphalts in the Midwest, as well as recycled tire rubber asphalts in the Midwest.
Thank you. And next is going to be Dan Troya from Spalding de Decker.
Good morning, everybody. Dan Troya, Spalding de Decker. We are a full-service civil engineering firm in Southern Michigan. We have about half a dozen offices between Detroit and Grand Rapids. We do primarily civil engineering for municipal clients, cities, villages, a little bit for the state of Michigan DOT. We also do land development, and we have a full-service survey team. Prior to that, I was with Ingham County, Michigan, and the Lansing area for about 23 years and designed a whole lot of road projects, did more than a dozen projects that utilized rubber modified hot mix asphalt pavements.
Thank you. And Professor, we just introduced you, and you're not a manufacturer, so I'm going to hold you for a couple more times here until I ask you again. So, okay, David, I want to ask you, what motivated you to explore and then become a manufacturer of devulcanized rubber?
So the business was started to specifically recycle rubber, and an evaluation of the sides of both the problem and the opportunity led us very early to conclude that devulcanization was going to be necessary, if not sufficient, to allow us to recycle a sufficient number of end of first life tires into products and materials. And to expand on that momentarily, one needs a broad set of applications, and to be able to meet a broad set of applications, to be able to reuse that volume of end-of-life tires, there needs to be a technical capability as well as an economic framework that makes those products applicable to that broad swath of applications. So the company was born and has continued to develop to pursue that goal of trying to get as many of these end of first life tires across the bridge into some sort of reuse, a broader set of reuses than traditionally has been the case prior to the commercialization of devulcanization.
Thank you. John, real quick, let's try to make these be about a minute long, a minute and a half, just because we have a lot of questions.
Yes, well,
maybe you were brought in later, but that's okay.
I'll try to make it really quick here. So we've obviously looked at several different rubber methods each year of the last 25 or 30 years. Always looking to improve what we're doing, which is just using a 30 mesh minus and doing it terminal blended and not shipping it until we certify it to state spec. 2023, I was contacted by agencies and Spalding de Decker and introduced to the NRT method. In short, we tried everything we could to check it off the list as just another flavor that didn't work, and we couldn't find a reason not to use it. This was one of the only devulc products that we looked at that actually we could meet a polymer spec with a couple waivers, and was easy to use, and most importantly was by far the most cost effective.
Thank you. I guess I'm going to go back to you, Sean, at the end then. Dan, you, I know, introduced David to Don. So why don't you go ahead and tell us why you found it real important to use debulk? You're muted.
Mute, Dan.
Mute.
There we go.
Yeah.
Sorry. As I mentioned, I've done more than a dozen projects with recycled tire rubber. Probably 6 or 7 of those were crumb rubber. And, we had a modicum of success with those, but at one point we tried a devulcanized rubber product. It was different than new rubber technologies, but this is about 10 years ago. And I discovered right away that devulcanization had some significant advantages, namely when you're adding crumb rubber to an asphalt mixture, whether you're doing it at the asphalt plant in a dry as an aggregate, as a dry additive, or whether you're doing it at the terminal, the rubber does not melt into the asphalt cement, even though it's 360 degrees Fahrenheit. It stays in suspension, and it gets soft around the edges, and you get some of the beneficial chemicals from the tire that escape into the binder, and those things, the things that keep tires from dry cracking and deteriorating in the environment. Those chemicals are good for the asphalt pavement as well. So the beauty of devulcanization is it allows that rubber to melt and mix homogeneously in the asphalt cement liquid. And so now you get all the chemicals that are in the rubber that can be utilized by the asphalt pavement to keep that asphalt flexible for a longer period of time, and it makes a longer life pavement.
Great, great. Okay, Sean, you're muted too.
Yeah, one of the reasons, we have an extruder line that does the rubber mats, a sheet line. So some of the challenges that we have there is running that, we use an SPR crumb. We have a single screw extruder, and we do have issues with mixing all of our product together. So through trial and error, even when we run a reclaimed material, which is already kind of reprocessed, we have a lot more success. So we kind of reached out to New Rubber Tech and worked with David's team there and tried to develop a pellet. So that pellet would have all the ingredients that we want in it. So we don't have all these different ingredients and have to worry about a recipe itself. And then also trying to implement some recycled material of our polypropylene wall liner into the pellet as well. So with the trials that we've done, and it seemed to be a lot more promising. Like Dan was saying, the mixture, it seems to mix a lot better. We get a lot better surface finish, and you get a lot more consistent product as far as hardness and tensile. So that's kind of the root. And obviously the other part of it that I like as well is that it simplifies the process as far as the operators can stand. But we've had a lot of turnover, so it's a lot easier to manage training when they're not dealing with recipes, and we can kind of keep an eye on how they're using that material, because it would be one pellet instead of them kind of reaching over to get put in more of the more expensive stuff to kind of band-aid the issue. If that makes sense.
Yeah, no, that was great. Thank you. I think it's great when we can actually have users. A lot of times on panels, we don't always get to see the manufacturer and the people that are actually using the material. I think it's really important. So that's why we've gone this approach. We've had a couple of these panels before as well. The next one, David, this is going to be just for you, followed by Anil on another question, or the professor. So this has a couple of parts to it. First of all, I want to have you give us a very short version for the layperson, the kind of the definition of devulcanized rubber. I also know that each of these people that use your devulcanized rubber use a different form. So I want you to briefly share that as well. And then what are the most relevant considerations for a potential user? of devulcanized material? And I'm also curious why you chose to use mechanical chemical devulcanization all within a few minutes. So there you go.
Okay, so as the professor referenced, devulcanization is the reversal of vulcanization or the curing of rubber. Put it into a layperson's terms, what I'd use an analogy to try to make it easy to understand. If you think of a granulate piece of tire, end-of-life tire, as if it were a breadcrumb or a stale breadcrumb, what devulcanization does is turn that little breadcrumb into a little blob of dough. And that little blob of dough can then get aggregated into larger portions of dough, which then have a utility to go down one of a number of different roads, inclusive of the reinsertion of, to keep the analogy going, yeast or a curing agent, which allows you to bake a new loaf of bread or whatever other sort of product that you're making. So from a layman's perspective, just think of it as a way of taking the solid material and turning it back into a super viscous liquid material, which then can be taken down one of a few different applications. What are the considerations for a customer? It's technical performance, economics are the two crucial elements. From a technical performance perspective, that comes down to physical properties that can be derived from the material, not only as a devulcanizant, but in a second order reincarnation or use of that material as reformulated for a particular application. And physical properties can be measured. So the good news is the efficacy of this technology can be measured at the customer level. Another very important piece of usability or the consideration for the customer from a technical perspective is the processability. It's one thing to have a material that has the right physical properties, but it's got to be processable by the customer in its existing infrastructure to be interesting to that customer. And as you mentioned, Denise, that means the form factor of the material has got to be a little bit different depending on the application and what the customer needs. Lastly, why did we choose mechanical chemical process? A few different reasons. We were trying to use as an environmentally friendly process that would yield the right capital and operating cost economics. From an environmental perspective, the chemistry portion of what we do is all FDA approved food and medicine grade materials. If you've ever consumed a pizza, you've consumed our chemistry. If you have ever used a decongestant, you've consumed our chemistry. And the chemistry does one of a number of different things, but an important aspect of it is it acts as a catalyst, which then reduces the amount of energy input required for the mechanical implementation to do its work, which then speaks to lowering the cost of the material. An important element of the architecture of the mechanics is it comes back to the technical piece of this that was described earlier. What one wants to do is break crosslinks without disturbing the main carbon chain. And heat is your enemy in that regard, which is why we do not have any thermal content in our process. We start at ambient temperature in the material. While it exotherms during the process, it comes out of the process at less than 80 degrees Celsius. So no thermal input. And that's how one ensures that the carbon backbone of the material is best preserved.
Thank you, David. Okay, Professor, this is your question. Can you briefly explain the science and advantages of devulcanization compared to traditional chrome rubber, GTR, some people call it that? What makes devulcanized rubber particulate a game changer for reinforcing recycled rubber into higher performance products?
As David mentioned, that if you have a devulcanized rubber, completely devulcanized rubber, processing will be great. And the more the devulcanization, more you can put into the virgin rubber compound, and you can make it more effective. Right now, the problem is that whatever devulcanization process we use, we cannot get 100% devulcanization. And also we have main chain breakage. So what happens, the properties are inferior. In fact, some of the properties of devulcanized rubber, if you look at, you will find that you achieve hardly 10, 11 MPa strength, okay? And for a tire, you need much more than that, 19, 20 MPa strength, tire tread material. So it is obvious that we have to achieve that the strength of the material. And in order to do that, devulcanized material will be better than simply using a crumb rubber or buff rubber into the tire compound. Because when you use a crumb or a buff rubber into the original virgin tire compound, they act as floor. Whereas if you use a devulcanized rubber, they get along very well with the virgin rubber, and they get co-vulcanized with the rubber for making tread or whatever compound you make. And that gives you additional advantage.
Hey, thank you very much. Having met with tire manufacturers myself, even, they have said that they talk about it not being fully you can't fully devulcanize a tire. The good thing is we have other uses, and everybody thinks they're going to put material into a new tire, and so many businesses are started thinking that's what their goal is. But what I do know the manufacturers want is consistent quantity, got to have competitors. You can't just have one sole source. So it's a challenge when people think it's going to go back into a new tire. So just so you know. That's my opinion, but I have discussed it with them several times. Okay, my next question is going to be about quality, or a couple of them: quality, performance, and durability. Many manufacturers and specifiers are concerned about consistency when using recycled materials. Please discuss your experience when using crumb rubber, devulcanized material, or other. And I'm going to direct this first to Dawn, because Dawn, I know you've tried a lot of different materials.
Yes, thank you, Denise. Well, I guess first let me say this. I've been an end user of a lot of different methods, and starting off with I've done plant blending, taking crumb and blowing it in at the hot mix plant. Currently our main method at Seneca is to use a crumb and put it in the blending systems, and about 24 hours later we have a steady state and a product that can be tested and certified and sold. I'm going to say that the most important thing for consistency is having the ability to make sure that you monitor and have control over that product. Frankly, I was never a fan, and there's not. There's a good way and a bad way to do everything, but it's very difficult to be consistent in an end product with dry blending at a plant, blowing it in, and such. When you get into the terminal blend, you have a lot better product and a lot more consistency. And as Dan can probably attest, from an engineering standpoint and from an agency standpoint, they like the certification paperwork before it's ever loaded into a truck and delivered to a hot mix plant. What I see as bringing this around full circle here to this method, this topic, specifically the NRT that I've been using now for a couple of years on some projects. It is quicker to blend in and get my end product. And that product doesn't waver very much, if at all. And so what we follow a recipe and we know what we're going to get at the end. So it has provided a lot more consistency. It's I'll say slightly better than the method that we've employed for the last 25 years of the 30 mesh minus being terminally blended.
Thank you. Sean, how have, how have you maintained or improved the product, or if you have, improved the product quality, performance, and durability when using the devulcanized rubber?
Yeah, I think Don touched on it a little bit. I mean, the biggest thing that I see we struggled with is getting, we use a crumb as well for the last few years, an SPR crumb, and basically got a lot of inconsistency. So we're getting a lot of different sources from different areas. And what happens is that this changes settings. So it's a lot harder for the operator to adapt. So what will happen, we will get a lot of surface defects. We'll have to, rechange how we run it as far as temperature related, which causes scrap, downtime, all that kind of stuff. So when we go to an actual devulcanized pellet that we've been trying to work to, the consistency's there. So it's already kind of pre-mixed. The flow, it flows better. You get a lot more, surface finish. Basically, right out of the gate, you make a good part instead of trying to hone it in based on a certain batch that came in that were maybe a little bit unknown of the quality. So, I mean, it's something that we check on a daily basis, check hardness, tensile strength, all that. We try to manage it that way. But we see a lot more consistency that way when we run a pellet than we would if we're getting a lot of different lots of material from different various sources.
John, I think you received from New Rubber Technology sheet rubber. Is that correct? That process, or which one do you get? What form do you receive your devulcanized rubber in?
No, this would.
Is that you? No, I said Don. I meant Sean. Sorry.
Okay, sorry.
I meant Sean, not you, Don. I know what you're.
I think this is you're talking about the agricultural side. Is that?
Yes.
Yeah. I think David Beber talked to this. I'm kind of more the fleet side. I'm kind of filling in for Ross right now, but yeah.
So Legend, as Sean mentioned, has two businesses on the agricultural side. They predominantly consume rubber compound, which we have initially supplied to the agricultural side of its business in sheet form. So we take the devulcanized rubber and we actually take it a step further. We turn it back into a rubber compound, inclusive of having cure in it, so that Legend can then put it in a press and cure it. We also manufacture those same sorts of products for Legend. But on Sean's side of the business, on the fleet solution side of the business, it's a thermoplastic elastomer that we are sending Legend Fleet Solutions, and that is comprised, the majority of the composition of that material is devulcanized rubber, but it also includes plastic. And because the rubber is devulcanized, it and the plastic actually is very homogeneously blended. It actually interacts at a molecular level as opposed to what, say, crumb and plastic would be capable of doing. So very different form factors depending on the different applications. In the case of asphalt, it goes in as a granulate, but a granulate that has a lot less bulk density than crumb. And I would, again, use an analogy. If you think of crumb as a kernel of popcorn, the devulcanized granulate is like a popped kernel of popcorn. Less bulk density and a morphology very similar to popcorn, lots of open receptors, what have you.
Okay. Don, this is for you. I know you've moved tens of millions of hot mix pavement over the years. Have you found that even though you say it's maybe not a lot of change, but it is better, does it help? Can you say that it helped with durability, noise reduction, rutting resistance, or life cycle costs? Any of those things?
Okay, speaking from a larger umbrella, there are definitely things that have been proven out in real world testing. I think the NCAT test track is a great place to point people for that information. So I have not dealt with devulc long enough to be able to have firsthand knowledge, other than the point that we are now a couple years into the demo projects that I have been supplying to the contractors. And those have all looked like they're performing very well. Dan can probably attest to that a little more so than I. But there's one point that I will caution everybody on, and that is no matter who is involved in having a product or making an asphalt binder to sell to the industry, if it contains rubber, there's all kinds of things that people will use and say. So you really have to be careful and really look at data. Be data driven and not subscribe to everything that you read. There's people that talk about, the ground tire rubber or recycled tire rubber pavements are so much quieter. Anyone that works with mixed designs can, without using any rubber, make you a noisy pavement or a quieter pavement without changing the modifier of the asphalt. So there's a lot of noise and a lot of chatter in some of these things that you have to really get down to the truth of the matter on these things. Now, with all that being said, I am using it and plan to still use the devulc system that we've provided here the last couple of years, because we see everything we see with it is, I stopped short of saying game changer, but almost a game changer in being a next generation as far as what we see.
Okay, thank you. Dan, did you want to comment or not? Or is that enough? Or
yeah, I was just going to add, Dr. Vollmick pointed out that, all tires are not the same, right? They have different compounds and different percentages of virgin rubber and all of, different chemicals. So I think that's another thing to be careful for, is that for devulcanization, well, and there's many different methods of devulcanization as well. So you have to monitor the tire stream. I think in some of our conversations, I think we discovered that maybe, I'm probably speaking a little bit beyond my expertise, but car tire rubber might be better for asphalt modification than truck tires, for example. But I do have a project that we did 10 years ago with a prior edition of a prior company's devulcanized rubber, which I'm not going to mention any names. That project is performing very well. Half the road is devulcanized rubber, and the other half is a high performing polymer modified asphalt, and you can see the difference to this day. The one with the tires, not only is it performing well in terms of rutting and cracking resistance, but it's all still nice and black. And part of that's because it's got carbon black in it. And carbon black, what does it do? It shields ultraviolet radiation from polymer elements. So if you're in the civil engineering industry, one of the things that we do a lot of is we buy geotextiles and geogrids, fabrics, right? They're all, most of the time they're black. Well, that's carbon black. That's done to stabilize the plastic from deterioration from ultraviolet. Well, if that's good for geosynthetics, it's good for asphalt too.
okay, great. Sean, let's see. I got to make sure you haven't answered this one. What performance advantages do you see in using devulcanized material?
Yeah, I guess I already touched on it a little bit,
I
but
think you kind of answered it, but go ahead.
that's fine. No, the biggest thing for me is the consistency. I mean, that pretty much sums it all up. What you get in is what you get out, kind of thing. There's a lot of mystery behind the raw materials that come in when you're getting really good deals or big bags of SPR for free. Usually that doesn't run very well. So basically, having that that processed material coming in, knowing that you're getting the right hardness, it flows a lot better. I mean, it is a night and day difference as far as quality and throughput. There's a lot more uptime on the line. Like I said before, this line that we have is not a very fast moving line, but so if there's an issue, we're only running around 3 to 4 feet a minute, which is very, very slow. So if there's an issue, that issue can take a little while to resolve, which you're down just making bad product. So the quicker you can get that thing producing good product, which we can achieve with using a pellet like that, is huge as far as throughput and cost saving.
Okay, great. We're going to now switch to sustainability and circular economy. For quite a few years, we've heard the tire manufacturers talk about their sustainability goals, and we know that's kind of a driver in our industry. My question is going to be I'm going to ask, Sean, I'm going to ask you one more. Is that a focus when you buy or are working on projects, sustainability, circular economy, or any of those things a driver for your company?
Yeah, absolutely. I mean, probably in 2022, we got an award, an environmental award. Basically, I'd say 80% of our products, we have a very big content of recycled material in it, not just rubber. We do have a lot of other material we use. So right out of the gate, when we do look at it, Ross, our owner, he's a very crafty guy and gets his hands into everything. So we're always looking at a way to recycle any waste streams that we have. We either try to put it back into the product, like we're trying to do with David as well. And also there's a lot of requirements from the customer as well that are aiming for more sustainable products. So they'll ask you on certain things that we need to have a certain amount of recycled content in there as part of their requirements. So we're seeing that a lot more lately. So this is something that we always take into account.
I don't know which one, it should be you or David, but I understand you're also taking you have a project where you're taking plastic, sending it to David or something like that, and then going back with your, let's see, well, David, why don't you share it? Because you shared that with me just briefly.
He did touch on it a little bit, but yeah, go ahead.
Okay.
If you want.
As Sean mentioned, they make a rigid flooring that is made from a plastic polymer composite, and the sheets that they extrude are then die cut, which creates the offcuts, which Legend then granulates and sends back to us. We then blend that with our devulcanized rubber to send back the Eco-TPE, which they then sheet extrude into a soft material rubber, really a thermoplastic elastomer material, which is then an overlay in some cases for that rigid flooring. So it's a modified circular approach, and there are lots of these sort of modified circular approaches, which I think are the more realistic approaches nearer term, in addition to some of the broad swath, huge volume applications that I think the asphalt industry represents as well.
Well, this is why in developing any product, one of my slides I usually show is about the relationship and all the different parts or people or relationships you must build. And I know it's been a lot of effort with all of you guys working with David is just matching up people with the right product. You had another one, David, you mentioned to me with nitro. I don't know if you can talk about that yet or not, or can you? Kind of a closed loop system?
Yeah, I guess let me sort of frame it first. I think that a lot of people view recycling perhaps in a simplistic or its purest form, right, which is purely closed loop, which in the case of waste tires would be the material going back into tires. that does happen, but it happens in such a small proportion that it doesn't really help fix the issue. I think we're on a continuum. That proportion is going to grow over time, but in the interim, other things are going to represent more of the volume. When it comes to circularity, I think that is going to be much, much more applicable to different kinds of polymers than what go into tires. So EPDM and nitrile would be two kinds of widely used rubbers that same devulcanization capability that applies to tire material also applies to those kinds of polymers with some process tweaks. We do have a customer that represents to me that they're the largest consumer of nitrile rubber in North America. And I think that sounds like it could well be the case based on the volumes of material that they're asking us to granulate and devulcanize. So so that they can take it back into their production process. And that would be, on the order of it's an evolving strategy. In some instances, it would be a minority of the material, but in other programs, it would be the majority of the material. So purely closed loop recycling, I see happening sooner in non-tire polymers. Non-tire polymers. Within tires, the proportion of replacement is currently small. I think it will grow over time, particularly in certain segments of the tire market. And I would put at the top of that list the OTR, off-the-road tires, big mining truck tires, where grip around a corner is not a main consideration. It's about abrasion resistance principally, and that's where devulcanized material actually provides a significant level of advantages. So it's within the tire market, it's going to be initially OTR materials. Another variant of a closed loop construct is that there's some mining companies that we're talking to that are wanting us to take their mining truck tires, devulcanize that material so that they can take it back into conveyor belts, as an example. So again, conveyor belts sounds like a not technical application, but it is actually very technical, but different than tires. And conveyor belts are carrying, in a mining industry, rocks, not people. So there's a greater openness to initiating an evaluation and adoption of reuse in that sort of an instance. So okay. Lots of different variants.
Thank you, David. Okay. Professor.
Yeah.
What solutions? Well, let me start. I'm going to give you two here. What are the biggest technical challenge from your perspective as a researcher or working with Rubber Forever, limiting wider adoption of devulcanized rubber, and what solutions or support would accelerate that progress?
Okay. My understanding is one of the bottlenecks for devulcanization operation, first is the collection of tire and not collecting it properly, in the sense that usually for devulcanization operation, all tires are mixed up and then we do the devulcanization. And what happens when you make these materials, each tire has specific characteristics. Each belt, conveyor belt, as I mentioned earlier, it has specific properties, specific rubber. And so if you mix it up, then there are problems. Like in the plastic industry, what we do, usually they are separated by NIR, separated by artificial neural network, by machine learning. They are separated into individual plastics. So I think this industry has to grow in that direction. Otherwise, when you have mix-up of different materials, then there is a problem of collecting the right source for devulcanization. This is the first thing. Second is, when you devulcanize, usually these materials are not popular because of the cost involved in devulcanization. So we need support from federal government actually in order to lower the cost of devulcanization, okay, and to improve sustainability in indirectly. Third is that when you devulcanize rubber, the properties are not as good as the original material. I think we have tried many types of different materials, but especially for tires, it doesn't match the original material at all. So that is a drawback. And the fourth one is that the customer acceptability. Like, for example, when it is a devulcanized or reclaimed rubber, customer feel it differently. And so this perception, this awareness has to be changed over the years by giving proper courses, by interacting with common people, and by telling them the good things about the devulcanized rubber, the environment, the sustainability. And then I think it's going to go much deeper. Those are the 4 points that need to be taken care of for pushing devulcanization into society.
Okay. All right, because we're getting a little bit short on time, I'm going to jump into I wanted to do a few other ones, but that's okay. We're going to do, let's see, I'm going to ask, it's going to be about market growth. Let's see, I'm going to ask, David, I'm going to ask the question, I'm going to ask you again, sorry, but I know you're the one that's out there manufacturing this material. CalRecycle, and I've worked with the Tire Incentive Program, and there'll be more discussions on that on Thursday on the second part of the morning on funding, does support devulcanization. They added that in several years ago. I introduced you to CalRecycle back then. And they do have in their Tire Incentive Program offer 40 cents a pound for the rubber that is used in the products that are sold. And they will discuss that further. What role, besides the Tire Incentive Program or just the Tire Incentive Program, do you believe would help coming from a state, from CalRecycle specifically, to help? Is it going to be education, market outreach, more money on developing the products, testing, all those things that we have done over the years, or research? What's driving demand, do you think, or what would really be the most help we could get from CalRecycle?
I would echo what you've said. It begins with education, and forums like this are important as a part of that education. Certainly the economic incentives that are put in place are quantifiable, meaningful, and will help. The third element, which I think is equally important, is just advocacy. And there's another very large state agency in California that is responsible for the majority of road paving spends, and that's Caltrans. It's advocacy, helping point manufacturers to different people in Caltrans, and being a part of a growing set of voices that say, are the specifications dead on what we need? Devulcanization can achieve, I'm going to simplify this, 9 out of 10 of the specifications written in a particular state, but there'll be one, like solubility, that can't be met because the material contains carbon black, which is a solid and cannot get through that solubility test. If you talk to asphalt chemists, they'll say it doesn't matter, but it takes their different interests that align behind different points of view. So there's an advocacy component, which I think is going to be important. And it's not just for CalRecycle to be helpful in that. There is a role for CalRecycle to play, specifically in California and specifically with Caltrans, in my view. But there are other industry associations and industry partners that will slowly come on board. Don earlier mentioned NCAT, which is the National Center for Asphalt Technology. It's a as Don mentioned, it has a test track down in Alabama, another test track up in Minnesota. This is real world testing where they try to compress 10 years of road use into a year. And it's entities like that need to be testing these sorts of materials and need to be gathering data. So we need independent corroboration. And I must thank Don. He was instrumental in introducing us to NCAT and suggesting that as a strategy and a path forward that needed to be taken. So all of the elements you mentioned, Denise, it's education, it's networking, it's advocacy, and all of those elements are going to help.
Thank you. Okay, I'm going to ask, because this might be our last one, I'm going to ask each of you. Well, I just asked the professor, but what is one recommendation, Dan, that you would, this is just going to be one recommendation from each of you, that would make a difference? What is the one practical recommendation you would make to a manufacturer, engineers, policymakers, fleet, or agricultural operators or end users to accelerate the adoption of devulcanized rubber technologies? Just what?
That's a tough question. In Michigan, crumb rubber is taking getting some traction and taking hold, and a lot of that development has come from the bottom up. In other words, local agencies, counties, primarily counties, have been sort of experimenting with assistance, some funding assistance from the state Department of Environment. They call it EAGLE. I think they sort of need to continue those programs until such time as the state DOT sort of gets on board. They've been pretty resistant and been a kind of a roadblock for us, where we all know we're onto something here. Like Don says, a game changer. I've used that phrase many times. We think the devulcanized rubber polymer is better than the polymer that the state DOT uses, and in the long term is going to be a lot less money and performs better in a number of ways. And so we need the state to kind of join on our bandwagon, and instead of sort of pushing back and allowing some of these local agencies to be the incubator of this technology, I think would be a great thing. They just need to sort of get out of the way.
John, same question. What would be one thing?
Okay, I guess dovetailing into what Dan just said, there's a hesitancy to look at rubber as just being so different than polymer modifieds that we got to somehow break down those barriers. And for years, you can, no matter what method you use, you can do things the right way and meet state spec or a specification. You can pass, AASHTO M320 and M332 testing. If you have a waiver, and that includes so far what we've experienced with Devulc, if the agencies are willing to waive separation and solubility specs. And once I think there's education to everybody, but once there's education to the agencies and the policymakers of what is this spec for, what is it doing, and is it okay to waive it for this, I think it opens up. It really opens the doors for this to grow a lot more. We're not seeing polymer type of smoothness in our solubility and separation data, but the fact that we're not seeing that is not a bad thing either. It's a good product. In fact, I would argue that it is better than polymer in many ways. And there's others like NCAT that have proven that out too.
Thank you. John? One practical recommendation for whoever you want it to go to.
Yeah, I think as far as my experience with it, is trying to understand how you would incorporate obviously the devulcanized rubber in that. And from my experience, it was the consistency aspect. I mean, I know that there's an additional cost to devulcanize. So if you're looking at a pound, for say crumb to devulcanize would be more. But it's kind of understanding that cost performance and understanding like the process in itself and how all the way through it, as far as like I got into kind of the training aspect, the machine, how it runs, all those different aspects add up and are sometimes harder to calculate to kind of justify going to a different, say, blend that might cost slightly more. But it's something that after going through this experience and seeing the different variation that we had and the low cost, like I said, we're getting certain rubber for free. Obviously, if it's free, it's free for a reason. But once we got into the more, the modified pellet, to kind of tailor it to our process, to our equipment, it'd be a lot more consistent. So we're not getting any, we won't get any returns from the customer. A lot of the times when we have different materials come in, later on down the road, we'll get some rejection from the customer, the mat splitting, or after it's been sitting out in the sun, it's been splitting, they're causing holes. So all this can be, eliminated by having more of a consistent product. It's just going down that road, kind of testing it, kind of tailoring it to what your specs are. And I think it'll all justify.
Thank you. Professor, did you have one thing? Otherwise, I'll go on to the next one. Did you have one more thing you wanted to say?
Only thing I want to tell you that whether you like it or not like it, devulcanized rubber is going to come in a big way because as you can see that the projection is very high, 10% CAGR from 700 million to about 1.5 billion rubber in 2034. So projection is very high. And also morally, we cannot make the environment dirty. You got to utilize more of the waste material, namely the rubber here. Because right now, I think we use hardly 35-40% of the total rubber back into the same product, but it has to be much more than that. And my only suggestion is, which I see, that there is not enough research being done in the area of devulcanization. I must say that number of papers have increased over the years, but it has to be much more because people have to be much more aware of using devulcanized rubber into the product. One other thing I want to tell you that like ordinary rubber, like if you talk about natural rubber has different grades of natural rubber. Devulcanized rubber, do you have grades? I think you can take it to STM or some committee and then discuss about it. Devulcanized rubber doesn't have probably any grade. I don't know.
Well, we are on ASTM because David and I work on that committee as well. The ASTM standards out there, 6814, is old. And so we have been working on classification so that we can do a better job. We have pulled in people that go to those meetings to talk to them as well. So you'll see changes on that. We got like just
so what I'm saying that the devulcanized rubber is a mixture of many types of rubbers. So what happens, ordinary people, namely the customers, are really confused because if you specify the grades, then they will use that particular grade for a particular application, and it will be much more helpful to rubber users.
Yeah, we agree with that. Okay, we got a time for just, I'm going to bring up one, and then I'm not sure how we'll answer this, if at all. One of the things, because of all the involvement in tire rubber that I'm involved with, is we see a lot of, we've been hearing about life cycle analysis, PCR rules, product category rules, environmental product rule declarations. I'm going to just ask Sean, do you guys deal with that, or has anybody asked you to prove that you have that already in place in your company? Any of those things? Because we are seeing it in many other areas that I work, from molded rubber products now to other things. So do you guys deal with that? Do you have an LCA, life cycle analysis, for your company? Just curious.
Not that I'm aware of, actually, honestly.
Okay.
Yeah.
All right. So is any of the, let's see, David, you and I have talked about this. So technically this is a movement that's happening right now. So it is another way that CalRecycle, if we got them more involved, might be able to help. I just want to throw that out there, because we just did one for recovered carbon black, and the company behind it was Burla Carbon. I am sure they spent $200,000 at least putting all this stuff together, because we had so many of us with opinions. But those are a movement that's beginning to happen in certain areas. So maybe not for you guys, but as a whole, molded rubber, they are trying to put one together right now out of California. So just so you know. Okay, I think we're going to go ahead and do you have any comment, any one of you? Because we've really got like 2 minutes left. Then I'm turning back over to Tommy. I do want to go ahead.
Again, I'd like to thank CalRecycle and all the participants here in the audience. And in the case there is a customer or potential customer in the audience, I just implore people to be open-minded. As customers in these industries know, there's data that will tell you the efficacy of a material. Be open-minded to try it, and the data is going to surprise you.
Sometimes you just don't know about it. You just got to talk to people to find out what information is really out there. I think my pictures disappeared, but I think that's okay. So anyway, I just want to say that.
Denise, let me interject something on the backside of what David just said.
Okay.
We've looked at all kinds of snake oils, as I mentioned, through the years, and a number of products. And interestingly enough, I learned some things from Professor today as well, that you can't just lump some of these things into a category. You can't put it in a shoebox called devulc. And that makes sense, because we looked at some products that frankly don't work for asphalt modification, but they might work for other aspects. And that colored our approach to evaluating material when we got the call initially. And we heard, devulcanized, and immediately it was like, let's not waste our time. And we know that doesn't work. So yes, David, you are correct. I think everybody needs to have an open mind and look at data, which we did. And it was one of the few things that we saw that, would compete or even surpass what we do on a daily basis with our method. So I will admit that I was too far into this. There's no such thing. You can't put a fried egg back into a shell as a raw egg. And David, with your popcorn kernel analogy earlier, well, I can't unpop the kernel. So all that being said, I went into those initial calls, admittedly, as being very negative and expecting it to not work, looking for any reason to tell you and Dan to go, hit the highway. Don't bother me anymore, type of thing. So yeah, I'm happy that we were data driven and open-minded.
I want to thank each and every one of you, Professor, for your time in presenting today, for a summary of CalRecycle's report. So, I've got to work with a couple of you before. I think you're great. So thanks for providing a different perspective from a customer point of view. I think that's important. And call David if you are interested in trying it out as well. So, or the experts that we have on the phone or on the call here. All right, I'm going to turn this over to Tommy, I believe, who wants to kind of close this out.
Yeah, thanks, Denise. Appreciate it. Yeah, thank you again to our panel today. Lots of great interaction. We appreciate it. And I'm going to share my screen. All right, awesome. Let me just show my webinar so I see everybody up on there. Great. So thanks again to our panel. I appreciate it. Our next workshop is going to be Thursday, 8:30 a.m. To 10 o'clock. And that one is Environmental Insights, where tire meets the environment. So we do hope that you will be able to join us. That's going to be that'll be a 90-minute session, and then again we'll have the break from 10 to about 10:25 before we finish with our final session of that day, which will be the program and grants accelerating progress in tire recycling.